right, I'm going to go over it. And I don't know, you decide how you want to do your study sheet, right? You might need more detail, less detail, it's up to you. But basically, right, you have to determine whether or not it's SSA, right? You have a pair and another side, then you know that, right? If it is, then you have to go into one of the two camps, right? Is it acute or obtuse? If it's acute, the angle that you're given, then the diagram will look something like this. If string is less than the rod, then you have to compare the string to the height, right? So you would have to find, right, height is r times sine of theta, right? Whatever this angle is here. And then you compare the string to the height, and there you could have 0, 1 right triangle, or 2 triangles, right? Versus if it's obtuse, it looks like this, right? No need to find the height. So if string is less than or equal to, right, even if they're exactly the same, you can't have a triangle. And if string is bigger than rod, then you have 1. Okay. This is just not telling me though what happens when the string is bigger than the rod, right? My simplified version would not have that because I don't need to know that. I know that it's 1, right? I know it's 1 when that is happening. This is kind of just what if I have to discern further, right? Very simplified flow chart. Okay, but students get very creative. You actually surprise me sometimes, and I actually at the end of the year, if you don't want your study sheet, leave it in your exam booklet, right? I'll take it from you. I look it over. I'm like, yeah, that's pretty cool, right? How you did that. Right. So let's go through this. Acute for sure. We have a pair and we have another side. So we know this is SSA, and we know it's acute, right? So now we know what we're dealing with. I would always suggest you start with your diagram. This is 67, which is angle D. And side D, make sure that the side that's across from it goes here, right? 19. And this is therefore 22. This is what we call the rod, and this is the string of the fishing pole, right? And then we go ahead and say that string is less than the rod, so we have to continue, right? What's the height? I don't have the key on me, so you're gonna have to bear with me. But yes, the answer is that you have to round to 2 decimals and you go by that number, okay? So 22 times sine of 67 is 20.25. And we are in centimeters, right? So now I take the string, I look at the number, and that's less than the height. Therefore, no solution, right? No solution. This one here, I notice an angle and 2 sides, right? But I don't have a pair. No pair. Not SSA. 1 solution. No need to find the height. No need to do anything there. You're done. This is actually SAS. It's cosine law, right? Cosine law doesn't have a problem. It's only sine law, and it's only SSA, because the other two are ASA, which has 2 angles, right? You can find the third, find your pair, but there's no ambiguity there. We can handle that. We can work with that. Next, pair and another side. So this is SSA, and it's acute. So R goes here. 5.9 would go here, 6.7 would go there. Rod and string, make sure you have that, right? I'm already simplifying that for you. So this is true. So therefore the height, I have to take this side, the slanted, multiply it by the angle that's touching it. That's 5.62. And we can tell that the string is longer, string is bigger than the height. Therefore, there's 2 solutions. And you can imagine this is swinging, right? Like if this height is 5.62, right? This is longer, so it's going to make contact here somewhere, and it's going to swing back and make contact here. So you've got your two triangles, right? And the next Y and Y, so that's a pair, and another side. This is SSA, and it's obtuse. So the nice thing about obtuse is you don't need to find the height. You just need to make sure you make it look like this. Y goes here, and 75 goes there. 68 would go there. This is the string, and this is the rod. String is greater than rod, therefore one solution. So if you know what you're doing, this shouldn't take you very long. Okay. Just make sure you always finish your, make a conclusion, right? How many? Specifically, you can say how many triangles, that's fine. But there it is. Make sure you have this on your study sheet, because when it's exam review, or if I bring this up on different tests, you need to be able to go on your study sheet and follow it, right? Okay, you can keep this. And I went through, like I was debating, what am I going to do for review, right? So I will give you a list of questions in a bit that I went back to the whole booklet. I'm like, you know what, these are pretty good. And chances are you didn't do them all, right? So I will do that in a bit. But before, I will just give you a bird's eye view, an overview of what have we done, what should you be able to tackle at this point. So chapter 3 and 4, test review. Where should you write this down? I think the back side of this booklet. I should have added more blank pages. But you know what? You know where it says extras, like on page 116? The destroyer question? You can just use that as if it's, we're not gonna use this question. So you can start writing down on page 116, call it test review, and just write this down there. Maybe I'll do the same. Yeah, I'll just do the same. You know what we're doing here. Okay, there we go. So I'm just going to call this test review. Yeah, the test is not first period for once, right? Yay. So I'm just going to run through some scenarios. I'm not going to solve anything now, today, right? But you should be able to tackle everything that has to do with a right angle. So this is a classic question, right? You start here, you're standing here. Just make a straight line going out away from you. And let's say there's a tall structure, a tower of some sort. Okay. You should be able to answer questions that deal with angle of elevation. So you go to the top of the tower like this. There's angle of elevation is going to be mentioned here, right? So let's say this is 50 degrees. You moving closer, or someone else is standing closer. It depends. Just read the question. And you look up again. Now you have a 60, right? The closer you get to something, the higher up you're going to have to look. And they would tell you, they would have to give you at least one side, or else you can't do this, right? So they might most likely give you this, like this. Let's say this is 20 meters that you're walking towards the building, or someone else is standing 20 meters away from you, still facing the building, looking up to the building? So what would you do in this case? I would expect you to see the supplementary angle here, right? If this is 60, then you would have to know that this is 120, right? So I'm actually using pen for stuff that you would figure out. So that'd be step number 1 right here. I'm going to put a little 1 there. Step 1. Now that you have 2 angles inside this triangle, you can find a third angle, right? Oh no, mental math. This is 170, so this would be 10, right? So that would be step number 2. And so I really encourage you to, on diagrams, add things like that, right? Use different colors, stuff like highlight. And so now you should be able to figure out everything else, right? So ultimately, they would ask you probably, what's the height of that building? Right? What is the height of that building? So you kind of have to inch your way in. As it is, you can't figure it out just yet. You need this slant here, or you need this slant. You need one of these slants to be able to figure out the height, right? So that I would expect you to be able to answer questions like that. Another one would be a little different. It's a variation of this. So again, let's imagine you're here and you're standing further away. And this one would be maybe something like this. There's a structure here. But on top of that structure, let's say there's an antenna. Right? And the question would say, well, looking from the bottom to the base of that antenna, right? Let's say that's 20 degrees. But then looking from the same spot, you're not moving. You're just looking up to the top of that antenna, right? We are told that the whole thing is 30. And they would have to give you a bit more information. They'd have to give you at least one side. So let's say that the direct distance to the top is 200 feet, let's say. They have to give you one side. There's no way you can do it without doing that much. And so here, you would obviously assume that there's a 90 here. Unless this structure is slanted, you're assuming it's vertical. What else can you do here? You see the 20, you see the 30, right? If this is 20 here, then this little bit here would have to be 10, right? To add up to the full 30. So you figured out the 10. This would have been step number 1 in my books. That would have been step number 1. A bit trickier here. A bit trickier. If this is 90, so focus on this one right here. This is a 90. If this is 20, what's this one going to be right here? 70, right? So when you think you're stuck, think again. Zoom out. Right? So this would have been step number 2. And this isn't a good example here. This doesn't look like 180, does it? Because of the little bend in, but we're just going to assume that we're considering that straight line. This is 70, and this is 110. What's up with all the 110s there? Okay. That's the third, right? And now technically this triangle, this is 10, This is 110, so that adds up to 120, right? What would this one have to be here? 60, right? So when you find angles, just keep thinking, what can I do? What can I do? What can I do? Sum of triangles is very helpful. If you look at this obtuse angle triangle right here, you have a pair. Right? And technically with this 10, that's all you need to, for example, just figure out the height. Like let's say they wanted this. Let's say the question was saying, hey, figure out just the height of that antenna, right? Or the whatever is on top of that building. Figure that out. Right? Maybe they want to find out the whole length from the bottom to the very top of that. You might have to figure out why, right? You can figure out this piece right here, add them up, and you're good to go. Right? So there's examples for all of these in the book, right? And I'm gonna actually I picked specific pages for you to try. Okay, so this is a scenario. Let's look at both of these deal with angle of elevation. When you're at the bottom looking up, I would say angle of elevation as well. Okay, angle of elevation, you're looking up. But what if we have angle of depression? Angle of depression questions. So let's say there's the, let me just go up a bit. There we go. Let's say there's a hot air balloon. Nice hot air balloon, right? Anyways, so from up there, let's just make a point that is being noticed on the ground here. And let's make another one a little further away horizontally, a bit further away from it. So this is a classic where you notice two things on the ground. Maybe you notice, right, a building here, another building there. I'm going to be very specific as to is this looking at the same place ahead of you, or are you right in between them? I will make sure you know that, right? There's not going to be any ambiguity there. But let's say there's an angle of depression to the first one. So let's just make a line going straight to that one. If angle of depression is mentioned, folks, you got to make one of these. You got to make a horizontal line, and then I don't know. In my example, I have 25 degrees. Let's say it's a bit steep for 25, but hey, let's just go with it. And let's say that from the same place, you're noticing that second spot. Okay, and that angle is, let's say, 5 degrees. The further away you look, right, the smaller the angle becomes. So you have something like this. I would have to give you a side. So quite often, right? I won't say it's always, like it depends, right? Just look at the question, but it could be that I give you this distance between the two. And now you have it set up. You're looking ahead, right? Plane, balloon, cliff, etc., looking down ahead of you. That's the scenario, right? I might ask you, how high above the ground are you flying, right? So you always, it's not part of your triangle. Well, actually now you're making it, but you always remember that there's a height, right? the question might ask you for this height. How high above the ground would the plane be, or a hot air balloon, right? There's a couple things you can do, right? If this is 25 and this is 5, then I know that this is 20, right? Because this chunk here represents 5. The whole thing is 25, so you just get the 20 there. You have a pair already, okay? But you're stuck. Not really. This 5 touches the horizontal line, so you can bring this in like this. This is 5 degrees here. Alternate interior angles are congruent, right? So don't forget about that one. It's your friend, right? Some students do something with the 90, like, okay, there's a 90 here, right? If this is 25, then what is this here, right? That's okay, you can do that, right? That'd be 65 here. And once you have the 65, you can figure out this one, which you would quite quickly figure out that you just went alternate interior, you took this 25 down here, and then you find this one. So there's many ways to get there, right? You're with me, right? There's many ways to get there. It's all connected. It's all connected. You are right. You just got to be very careful what you're doing, what you're taking. Don't always make it, oh, the 20, alternate interior 20, right? No. Because this 20 is just here. It's not touching the horizontal, right? So be careful. Okay, one more on this page at least. Another angle of depression. Please don't think, okay, I got it. I'm just going to look at this. I got it. It's not always going to be 5,000 here. It could be that I give you one of these sides. It could be that I give you the height itself. So watch out, right? Here we go. Look at this. This is my finest piece of art here. Okay, so there's a chopper here. Oh, it's missing the back one here, right? I don't know how many they have. So, something happening there. I know it's angle depression. It's coming, right? And you're noticing something way back here and something further ahead from you. Do not assume triangles are symmetric unless it is an isosceles, right? Unless you see two angles that are the same. You cannot just split them in half, okay? You cannot do it. You can split them, but you'll be stuck. You won't have information, right? And so obviously the height is always something that you could expect. So let's say in fact that I tell you what the height is. And the angle of depression to this item here is 30, and the angle of depression here is 50. So now you're looking out. But remember the shark question? It could be that there's two divers looking at one object. So it's basically just this one flipped. It works the same way. So don't be too worried about that. I will just make a note here. Plane, balloon, etc. in between objects, right? So that's what this is giving. Height is given. Height given. That's very important here. And so you can be creative. To be honest, right now, and some of you might say, hey, this is 30 and that's 50, so that's 80. So this whole thing is 180, so I can figure out that this is 80. but it doesn't really help you much as is because you don't have the side across from it. Okay, just making observation. But what is helpful is to bring this 30 down here and to bring the 50 down here. That is helpful. And some of you are like, Mr. Dixon, couldn't I just have found that this is 90 here, from here to here is 90, because, right, this whole thing adds up to 90, so this has to be 40, and then 40, oh yeah, that's also 180, right? It doesn't matter how you get there, you would find that this is 50. And so quite possibly I will ask you to figure out the distance between these 2 points. So your task is to find x, find y, add them up, and then you're there. Okay. Okay, that's it for angle of elevation depression. It's not the only way. This is not the only way. Look at your quiz. You have the divers looking down, so it's basically, watch this. Well, it's basically a question like this, except for the numbers where it shouldn't be upside down, right? But you have your angle of depression for both divers looking at one object, right? It's the same thing, right? Same thing. Let's, I have to go to the back of this booklet. I don't know if you still have room. Whatever you can muster. One more thing here. Regular, I call this regular triangle, right? Oblique. No angle of elevation or angle of depression mentioned. You know what that means is that there's not going to be a right triangle at all. Okay, that's what that means. So let's say 5 hours go by. Speed, I'm going to add a speed question. Speed of A is 50 kilometers an hour. Speed of B is 75 kilometers an hour. And so they both leave the same place and determine the distance between them after 5 hours. That should be a pretty easy one, to be honest. Like, there's no compass direction, nothing like that. So just from here, A goes, we don't know which way A is going, so just go out. This should be A. And so we go 5 times 50 is 250 kilometers. And B is going faster, so I'm just going to assume that B is going to be further out. And so 5 times 75 is 375. So this is 375 kilometers. This question is probably going to ask, what's the distance between the two objects after 5 hours? Distance between after 5 hours. What's missing though? Can I solve it as is? Probably would have to give me either an angle. They would have to say that this is, let's say 70. They'd have to give you an angle, or they would have to say after 5 hours they're 500 kilometers apart. Determine the angle between their paths or something like that. So just, these are what I call regular triangles. No angle, depression, or elevation. You just interpret the question, just draw it, and you basically can't go wrong. You cannot go wrong. And remember, most questions are solvable using sine law for some reason. Last one. Compass directions. I'm just going to walk you through scenarios. I just made stuff up here based on what I saw, some of the mistakes on the quizzes, ACs. So just copy this. Let's say you start and it says, let me see here. I need to get my east-west right. East, 20 degrees south. You're starting there. So you go east and you turn 20 south. So you go here. Don't make it too big, but also not too small. Okay. So you go there, and then you turn or you pick something up or what have you, and you're given another compass direction, and this time it's going to be north 50 degrees east. North 50 degrees east, so you're going this way. I know I sound like a broken record, right? So I want you to remember that you are, on the test, not going to go, okay, I'm going to line up perfectly perfect, right? You're not going to do that. You're going to go short of that point, or you're going to go way past it, so it's definitely not a perfectly horizontal or vertical line. Okay, guys? We have a deal? If you get that wrong, you owe me $5, okay? I will collect it after the break. I'm just kidding. Okay, so what would you, so you know what? Can I give you a compliment you? You're pretty good at drawing this. This part you're good at. It's transferring. When we transfer angles, that's when we have a problem. We're making a lot of assumptions, right? So here, what happens to that 20? Something is going to happen. It's going to be useful. I'm going to bring that in. It's touching this horizontal line. It will touch this horizontal line here, right? So we bring in the 20 here. And then I want you to focus on this fact right here. Or something. I need you to focus. When that 20 is there, you're like, I have that 50 there, so I'm just going to make this whole thing 50, right? That's what I see sometimes. Like, I need something here. What's going on? This, of course, this forms a 90, right? You want to see it again? Let's zoom in here. See? There's a 90 there. So basically, if this is 20, then this part right here, this part, you guessed it, that's going to be 70, right? So that 70 is what's actually going to help you determine that whole angle. I hope I make myself very clear here. Okay? And so now the 50 and the 70 form 120. And you know what? That's probably going to be the only angle you get to take into the triangle. That's the only angle. Don't be putting the 20 in there. Don't be, right? So this is wrong right here. You're like, okay, now I'm going to make a clean version of this. All right, let's do this, right? You got the 120, you got the 20, and this 50 somehow that 50 goes in here, but I'm going to put it in there anyways, right? Nope, right? Those are not horizontal, right? We're not told that. The question has to be very obvious. It has to say, hey, when you travel this direction, you travel in such a way that you line up perfectly due east or west of where you started. Then we have a deal. Then we have this. But then it's going to be a lot easier, okay? So this is wrong. This is wrong. Don't make that mistake. The other mistake I saw, let's see this one here. I think I'm going to be done after this. I'm fairly certain of that, unless I get another idea. So let's say, similar scenario, okay, you're with me? Let's say it's we're going to start the same way as earlier. We're going to go east, 20 degrees south. Let's do that. So we go east and then it's 20 degrees south. So it's about that. I would strongly recommend you use a ruler. Okay, and this is your dashed line. This is not part of the triangle, okay? Then we turn, we're given another compass direction, and let's say this time it's east, 25 degrees north, right? East, 25, so that means that we would go like this, 25 degrees towards north, and then we travel. And remember, you owe me $5 if you get this wrong, right? You will go past it. In this case, I'll just go way past. You're not lining up perfectly, okay? Now what? Take 1 minute, figure out, is there a way to get an angle inside that resulting triangle? Go for it. Go for it. I'm just going to leave that there. That's it. That's all.